Hi, everybody. Welcome. I'm so excited to be here. I'm joining you here from Atlanta, Georgia. As mentioned earlier, I'm the engineering manager for Square's Refunds API team. Welcome to our lab on open protocols, where we're going to use TBD's Web 5 and the TIDAL API to demonstrate this exciting technology. There's some setup instructions. Sorry, is my slide showing? Okay,
Yes.
cool. There are some setup instructions on this slide that have also been shared in the chat. Go ahead and try to get that started. If you have any questions, we'll be monitoring that as we go. But it's my pleasure right now to introduce Kirah Sapong, who is a senior front-end open source engineer on TBD, and Clara Rendé, who is a software engineer lead on TIDAL's content team. Kirah and Clara are going to start off by talking about what open protocols are, TIDAL's API, and TBD's Web 5, and then we'll have a hands-on lab where we get to explore these technologies a little bit and share some playlists with one another. And Kirah, why don't you start off by telling us what are open protocols?
Absolutely. Thank you so much, Erin, and thanks everyone for joining. It's very exciting to see where everybody is joining in from. So yeah, let's jump right in. So what are open protocols? Well, open protocols are vital to shaping a more empowering future web, and that's true for a few reasons. So we'll go over that right away. Next slide, please. Great, yeah, so for the first reason here, so they provide such rules to let different apps work together seamlessly on the internet, and that means interoperability. So interoperability, it means individuals can choose the tools and services they like without being locked into one system, because they're able to actually take their data with them to different applications that are interoperable because they're all in the same ecosystem. So if you're built on the same protocol as another application, you know what data to expect, you know how to mutate it and transform it to fit your needs for your application. And users can benefit from that because it opens up a wide door of different applications for the same set of data. Next slide, please. So touching on that, so anyone can leverage an open protocol to create something new for the internet. This fosters a competitive environment where new ideas and apps can flourish, which is very exciting because this actually can seed new ideas, new markets, and it just levels the playing field for all kinds of different developers. Next slide, please. So open protocols are also more inclusive by design because anyone can participate in their development. This one's actually very important to me. So it means welcoming diverse perspectives that can better serve the needs of a broad range of users and communities. And as we're going more and more online, those diverse needs are evolving more and more. And to be able to provide that equitable experience, it's really important that we're opening up the door to more developers who can provide those experiences and serve those needs and serve those lived experiences. Next slide, please. So lastly, users benefit from open protocols because their data is never tied to a platform. So this means they can choose experiences that are aligned with their preferences for content moderation, privacy, security, and it helps safeguard individual control, user rights, free expression. You're not locked into a platform. Your data truly belongs to you. You have control over your data, and you can bring it with you to different interfaces and different clients that better serve your needs. We see this with email today. So IMAP, POP, SMTP. These are protocols that support email, that email is supported by. And for one, I have tons of email clients that I use. If I want to bring them all into a single interface, it's very easy and very streamlined for me to be able to do that. And that's because of protocols. So I'm really excited to walk through defining open protocols with everyone today. And yeah, let's get right into that. So next slide, please. So let's talk about closed systems and open protocols for a minute here. So we're more familiar likely with closed systems. What that means, users write data to a centralized data store that's beyond their scope of control. So data is served to individuals beyond the originating user scope of control as well. It's kind of a black box, what happens to our data in the middle there. All we know is we write something somewhere and we hope that it's served to the users that we want to see it. We hope that the moderation serves our needs. With open protocols, users write data to their own personal data store under their scope of control. Data is served to individuals within the originating user scope of control, and those other applications more act as a conduit for that data. But really, these users are actually reading this data directly from us, the source. Next slide, please.
Great.
I will pass it over to Clara. Thank you.
Thank you, Kirah. Hi, everyone. It's exciting to see that there are so many TIDAL users among the participants, and also so many people from Amsterdam, because I am also based in Amsterdam. So cool to know. At TIDAL, open protocols are one of the trends on which we are focused. On September, we launched the TIDAL Developer Beta, taking a significant step toward transforming TIDAL into an open and easily accessible platform. We want to build high-quality products that empower artists to thrive as entrepreneurs while connecting them more deeply with fans. It's the first time we are making a subset of our web API available to developers outside Block and TIDAL for beta testing, so exciting times. And we believe in taking an open approach to development and hope this beta will bring us closer to the developer community, resulting in more creative solutions for both fans and artists. So the TIDAL Developer Portal is intended to serve as the main source of communication around our open efforts, either directly via documentation and blog posts or indirectly by linking to other places. It also hosts functionality for developers to manage credentials used to access the TIDAL API. Next slide, please. So this is the TIDAL Open API, which constitutes the very foundation for allowing third parties to build upon the functionality we have at TIDAL. This release includes endpoints for consuming TIDAL catalog metadata, and we are inviting developers around the world to access our API and query and search our metadata, not the audio files, but the metadata. So you can now use artist names, contributors, tracks, and published information related to music tracks. Next slide, please. So as part of the beta, we are inviting developers to use our GitHub forum to ask questions and share feedback. So please, if you have any questions, doubts, or comments throughout this workshop, feel free to use the GitHub forum as well, and we will be happy to address them. Contributions from the developer community will be crucial in the long-term effort of shaping TIDAL's open platform. Next slide, please.
Great, thank you, Clara. So let's talk about Web 5 a little bit here. So Web 5 is an SDK that makes it very easy for developers to define and configure protocols into their applications. It provides a ton of wonderful utility helpers for building decentralized applications and platforms. And we're going to see that in action today, actually. Next slide, please. Awesome. So after this session, actually, I definitely want to encourage everyone and invite you to visit the developer site, developer.tbd.website. You can actually get started with Web 5 very quickly through a quick start, which is wonderful. Next slide, please. Great. And then you can actually go to the homepage as well and explore the code and see how our different packages are constructed. You can visit the README, and you can also visit our Discord with any questions you might have and just connect with our community that way as well. Next slide, please. Awesome. Okay, so let's go ahead and jump on in. Next slide, please. So the first thing we want to do before we get started with the lab is I just want to give everyone a chance to head over to the GitHub repo that was posted in the chat and clone the repo if you can. If you have a GitHub account, that's great. So you should be able to do that. If you don't, you can still follow along with us. We have some deployed links that were provided in the chat as well. I would say maybe hold off on clicking those for now, and we'll go through it all together at the very end. And then the next thing you want to do is also get a TIDAL API token. So you can log in, register an application. It's very quick, very seamless to do this. Absolute props to the TIDAL team for how quick and easy it is to get started with us. You'll get your client credentials from the application. You'll want to create a base64 token and plug it into the repo that you've just cloned under a file called config.js. So I think it would be a good time to maybe just pause for like 2 to 3 minutes, maybe 4, and just give everyone a chance to do that. If you're having trouble, please use the chat and let us know. If you think you're done, feel free to plug that into the chat. Either way, we'll go ahead and continue in just a couple minutes here.
So there were some conversations about not being able to cut and paste from the chat, but I think you should be able to just click on the link for the GitHub repo, and all the other instructions are also in the README in the repo. If people are having problems with that, please let me know. There was also a question about just what the steps were from the dashboard to get to the to actually create the API. If anyone's having trouble with that, raise your hand and maybe we can. I can share my screen and show you how I would create an app if that's helpful. I'm seeing someone's not able to copy the command. So the command echo -n part, if it's that, if you go to the repo, that is definitely in the README. So you'll be able to copy it from the README file in GitHub on a different webpage. It's not in Zoom. My job here is to find options for y'all. So, right. So someone's asking about the base64 credentials. Kirah, Clara, would one of you want to just like show you how you would like walk through just how you would do, maybe Clara, go to the title page, register an application, and generate the client credentials?
Yeah, sure. So if you just need to follow like the steps that are right now listed in this slide. So if you go to the login sign up link, you will see there that there is another link in this page that will give you access to the dashboard. And if you don't have a TIDAL account,
I'm sorry, Clara. I am going to share my screen for this and
okay.
do what you're saying to do.
Okay.
Right, so treat me, well, you know me well enough knowing that I don't actually know what I'm doing here, so we are good. So, all right, so I am on the title developers page, right?
Yeah, the login sign up.
Am I sharing this? Probably not. Let me fix that. Okay, so I'm already signed in.
Perfect.
But then I go to the dashboard.
So the first of steps for people that it's not logged in the TIDAL account, they should create an account, which is very easy, and you just need to follow the onboarding steps, and that's it. And then once inside this dashboard, you should create a new app with this button, exactly. Name it as you prefer, exactly. And then create the app. So here you will get, for the new created app, you will get one client ID, your client ID, and your client secret. You will need to copy those to be able to create your client credentials. So if you have a Mac or Linux operating system, you will be able to create your base64 client credentials with the command that we posted in the chat, and it's also in the README from the GitHub repo. So you should be able to do it writing echo, well, that command, and pasting there your client ID and your client secret. I'm not sure if you can show this, Erin, because the only...
I am going to try to do that right now. Hold on a second.
And there are some instructions also in the README for people who have Windows. So that should be pretty straightforward. But all you need is this client ID and this client secret. And once you have the client credentials, you are ready to, and the GitHub repo cloned, you are ready to start this workshop with us.
So let me see if I can share my terminal just so y'all can see what I'm doing here. So this is sort of the instructions, client ID, client secret, but what you want to do is go to that title page and copy the client ID and replace it with the value that you got. And I'm going to delete this app after this because I don't want these secrets out on YouTube, but for the moment, let me see. So you'll do something like that, and you'll get this big long number letter value.
Exactly.
And that is the value that you're going to want to use for the next steps.
Exactly. And you should copy this value, and we will paste it in the config file from one of the applications that you will see when we clone the GitHub repo. And I think that, yeah, Kirah will go through this in a few minutes. So, but with that, with those client credentials, you are ready to go.
Cool. I'm also seeing some questions about Windows and just getting one value. I ran this through last night, and when I did it, my string was long enough that it did a word wrap because the cert utils thing has like an 80 character line limit. So it's just, if it's just one value and it works, and that's fine. So hopefully this is getting us to a point where we can kind of move ahead. Can we just check in chat and just get a sense, does anyone have does anyone need some more help on getting this client ID? Yeah,
I'm just going to jump in for 1 second here. No,
Sure.
yeah, I just wanted to call out. So I saw a lot of people have one value that ends in 2 equal signs. That's definitely right. That's exactly what you want to plug into your API key there. So it should just be like a fairly short-ish, medium-sized string, and you'll just plug it right into there. If it doesn't have any equal signs, that's all right too. What you should get back is just a base 64 string. So if you plug it in, if you have any issues calling the API, when we get to that part, then we'll certainly try to troubleshoot that in the chat here. But I think we're okay to maybe move ahead here unless anybody is stuck anywhere in terms of getting the TIDAL account set up and getting your application set up.
While you're getting that set up, Clara, there is a question about song chord progressions that maybe you can answer. My guess is the answer is no, but I'm deferring to your expertise here.
Where is it?
It's in the Q&A.
Does the database have information on the song's chord progressions? I would say no, but well, that's a great question. Let me get in touch with the team, and we can perhaps we can grab all the answers from this workshop and send them afterwards in an email communication or something.
It's perfect. Erin, I don't know if you're able to go back to the slideshow.
I can.
Awesome. Awesome, thank you. Okay, perfect. Yeah, so let's go to the next slide here. So we'll cover a little bit of theory first. We'll set some expectations for what our applications will look like today. So getting started. So for this lab, we're going to work together to create a protocol that our application and many others can use. We'll decide how this protocol looks, what sets of rules will help us enable the kind of free interoperability across other Web 5 applications that we want to provide for our users. Next slide, please. Excellent. And we're going to decide our user experience here as well. So our app is going to present a list of song tracks to our users. We'll pull these tracks from the new TIDAL API beta, and our users will be able to browse through tracks and build a personalized playlist of their favorites. Because our app is based on a shared open protocol, our users will be able to access their playlist in any other client application aware of the same protocol. I think we're just getting a little bit of background sound as well. Oh, nice, thanks, Erin. Okay, great. So next slide, please. Okay, great. So let's talk about creating our users when we set up our app. So when we connect Web5 with our app, every user who visits our app will have what's known as a decentralized identifier, more commonly known as a DID or a DID. It'll be generated for them and stored in their browser. Their DID is used as a signing authority in the app, so only they and no one else can control their app interactions. This is like having a username and password, but in this case, our app never stores any information to do with our user. So just to cover that again, that's a DID, decentralized identifier. It's a personal app agnostic, unique identifier for our users. Next slide, please. So working with user control of the data. So what does it really mean to build a decentralized application where we don't store the data for our users? So each of our users will also be granted a local personal data store in addition to their DID. And a remote personal data store to sync data to, courtesy of TBD, while we're in a tech preview right now. These personal data stores are known as decentralized web nodes, or sometimes DWeb nodes, or DWNs. This is how users can interact with each other. DWNs are agnostic to client applications, and the same DWN can hold the data for a wide range of different client applications. So a DWN, decentralized web node, it's a personal app agnostic data store, and it can be local and or remote. Next slide, please. All right, so defining our open protocol. I'll pause here as well. If you have any questions about anything we've just covered now, what are DIDs, what are DWNs, anything around that, feel free to drop it in the chat as well. So let's talk about defining our open protocol. So we'll want to think about the different ways our users will interact with the data that's inside of our app. This can help us decide the baseline objects and relationships that we should set out in our open protocol. So we'll use schemas to describe our objects and paths to describe the rules and relationships for our objects. Rules refers to read-write privileges, and relationships refer to the relational mapping between objects. And we'll cover that just in a second here. Next slide, please. Okay, so anatomy of an open protocol. So we'll be working with three main concepts in our protocols. So types, it defines all of the elements that's used in our protocol. Structure, it outlines the rules and relationships between types. And actions, it describes the read-write privileges of different actors. So typically a protocol will be shaped like what you see on the right-hand side here. We have a protocol field that takes a string that should be a URL, and it's how our DWN can index and actually find what protocol we're looking for. We'll touch on that in the lab as well. We'll also set this to published true for our protocol, and we'll also set out our types, our structure for our types, and then our actions for each of the types in our structure. Next slide, please. So let's start with our protocol types. So let's say we have two types, playlists and track. So we'll call that just playlist and track. We can give each of our types a JSON schema that describes what properties we can expect in that type. If you were on the TIDAL dashboard and if you were exploring the API reference, you might have seen a tab called schema in one of the responses. And all that was just showing you what fields you're getting back in your response for a given track. That exact schema is something that you could actually plug into your track type here. If you had one for your playlist as well, so let's imagine that your playlist always has a title and an image to go along with it, then those two fields could belong in your schema. So that's how you kind of differentiate between types and schemas. Schemas describes all of the fields that you can expect in a given object, whereas the types are the different objects that your users will interact with in your protocol. Next slide, please. So let's say we want to have two top-level paths in our structure. We have playlist and track. We can also have a nested path, playlist/track. We now need 3 rule sets, one for playlist, one for track, and one for playlist/track. The rule set for playlist/track only applies when a track belongs to a playlist. Otherwise, the rule set for track applies. Next slide, please. So when would we ever need playlist/track? Why not just playlist? Why not just track? Rules are contextual and relationships help establish that context. So let's take an example where playlist is our root object. We have one object. We have this protocol path just called playlist. Within our DWN, each of these objects will also have a record ID to identify the object, a context ID to identify the context in which that object resides, and a parent ID to identify whether that object is a child of another parent record. So in this example, our playlist object has a record ID of playlist 0 and a context ID of playlist 0. Next slide, please. So when playlist is the root object, we can say all related objects are in the context of playlist. Within that context, we can also establish many parent-child relationships, which is different from our contextual relationship. So because playlist 0 is our context ID, and because that playlist object is the root object, the context for all other related objects, we can create a second object here. That's a track. It'll have a record ID of track 0. Its context ID is playlist 0 because it's within the context of our playlist. And its parent ID is also playlist 0 because it's a child of our playlist. Now, imagine we had a third type here called image, and we wanted to give each of our tracks their own image. We could also create another object, and we could give it like a protocol path of playlist track image. That would mean that it's nested under track in our structure earlier. Its record ID would be image 0. Its context ID would still be playlist 0 because it's still in the context of playlist 0. But its parent ID would be track 0 because it's actually a child of our track. Next slide, please. And by the way, I hope that this is all much more clear when we're hands-on, but this is a good opportunity to just kind of get into the theory a little bit. So let's talk about actions. We have 3 fields, who, of, and can. So who can be author, recipient, or anyone, can take any one of those 3 values. Of is optional and can be a related type. So if we remember, track was nested under playlist, we could then have an action here that's saying the author of our playlist is the only one who can write tracks to our playlist. And then can is the privileges that we give them. So read or write. If we wanted our track to be publicly available to anyone who wanted to see it, we could say who, anyone, can read. But if we wanted to make sure that our friends couldn't go in and just throw a bunch of songs into our playlist without letting us know, we could make it so that only we can write to it. So who, author of playlist, can write. Next slide, please. Okay, great. So we'll be developing 2 applications today. One is going to be Playlist Maker. You may see that folder in the repo if you've got that. It's going to allow users to obtain their DID, and it's also going to display tracks from a specific TIDAL album. And it's going to allow users to select their favorite ones and build their own personal playlist. The second app that we're making is called Playlist Finder, and it's going to allow anyone to input anyone else's DID that they have access to. So if I want to share my DID with Clara, she'll be able to put my DID into this other app and see what songs I've added to my playlist. In the real world, by the way, these applications do not ever need to share a repository. You never need to communicate with each other. All they need is awareness of the same protocol, and they can interoperate very seamlessly. Next slide, please. Great. Okay, so let's go ahead and dive in. I am going to take over the screen share. Thank you so much, Erin. let's start right here. Great. Okay, perfect. So we're starting here on the README, and I'm just going to go ahead and go straight into my playlist maker. I'd love it if everyone could follow along. I'm going to start at the config file. I'll be deleting this app after as well, so this token isn't out there on YouTube, but hopefully everybody's config file looks like this now. And I'm going to go ahead and pop into my index.js file. This is where a lot of the work for rendering our data exists, and we'll jump into this in a moment. But the first thing that I want to do together is open up the chat and get some suggestions from some people. I'm just going to see what we can do about building out this protocol based on what we know about the app we're trying to build so far. So let's start with the protocol field, and let's just see what suggestions we have. Do we know what we'd like to add to this field here? I think I see a question if we're going to be working on the front end alone. Effectively, so we'll define the open protocol, and that will be the bulk of this lab, but we'll also kind of see what we've done to render it. So we won't be doing a lot of hands-on with the front end, but we will see what that looks like on the front end afterwards. Yes, I can definitely give an example. I can give a hint as well. So our protocol just needs to be a string, URI, in fact, that DWNs can identify our protocols by. So we're going to pass it just an example URL, something like example.com, and we're just going to call it workshop protocol. So this is not a real URL, but we can absolutely use this in this case because our DWN is looking for this based on the protocol name. And we'll see why in a moment. But first, like the pattern that we'll be following is first we want to first see if a protocol is configured and installed. If it is, we can go ahead with the rest of our application. If it's not, then we'll install it for our user. Under published, do we want to do anything here? And I see a question about using the same string value for our apps to interoperate. Yes, that is correct, definitely. I see true, that's absolutely true. It's great. Okay, perfect. So under our types objects, what kind of types do we think we want to add here? I see playlist, definitely. Now our playlist is going to take an object and it takes a couple of fields in that object. Does anyone remember what one of those was? See who? Not quite yet. But that does belong in our protocol eventually, so we will get to that for anyone who said who of and can. I see action, and we're not quite there yet either, but that's great because everyone has a really good memory here. Okay, context ID, we're not quite there yet either, but I'm excited about everyone's memory. Schema, definitely. Good one. All right, so we're just gonna pass our schema string as well here. And this schema, we are actually working with schemas in the context of this lab. So in the scope of this lab, we're not actually bringing in any schemas. I'm gonna give it a dummy URL again as well. So we're just gonna say WWC workshop, say schema playlist. This is not a real URL. It's just an example URL. But this could very well, like in a real app, this could and would actually contain a JSON schema defining all of our fields. So one more field that goes in here is something called data formats. And that's where our DWN knows what to expect. So we're just gonna pass this application JSON into this array. And that's how our DWN will know that the expected data format for our playlist types is an application JSON. So let's move on to the next one. What's another type that we might include here? Okay, see image. We absolutely could include image here. In the scope of this lab, we don't need to. I see track, and that's right. I definitely want to encourage, though, after this lab, so you definitely play around with including different types, pulling them into your application, and just seeing how you can play around with those. So absolutely feel free to include image on your own protocol if you'd like, or you can just continue to follow along with just playlist and track for now. So we're going to use another dummy schema here. I'm just going to actually just autofill that, and then we're going to hit data formats for this one as well. And we're also going to pass the application JSON for this one as well. So this accepts a number of MON types under JSON or data formats, I'm sorry. So if we had an image type here, for example, we would be able to plug in something like, image PNG. There's a number of MON types that this does accept, like if we had, I think it's text plain or plain text, I don't know. But for the purpose of this, we're going to stick with application JSON. All right, so structure. What do we think would be our first field in our structure object? Any guesses? Okay, I see playlist title. So, see ID, I see ID. Oops. So what we want to plug in here for our top level objects are actually just the objects that we've created in our types. So we have effectively a flat list here in our types. The top level objects are always a given type. When we're defining our structure, we're going to revisit these types, and we're going to say that structure of our protocol should create given relationships between our different types. So I see playlist track, and that is exactly right. We're going to start with playlist because that feels like a good root object to start with. And we're going to start with a field called actions, which I saw earlier in the chat. You said that, really good memory. We're going to pass it an array of rules. And our first rule is going to do with write rules. So what would be our first field in our first rules object here? Yes, who. I love that. Really good memory. Okay, so we have who. And what might we want to plug in here? Author. Okay. Author. Okay. Got a lot of authors. So great memory, and we are going to use author soon. But because this is our root object, we want to make sure that anyone can create a playlist. So we're going to go ahead and say anyone for this very first root level object. For our next rule, we're just going to go with, or our next field, sorry, we're just going to go with can. Does anyone remember what rule this is for? Read. Well, read is correct, so we'll go with read. Read is definitely correct. Now I'm just going to copy and paste this, and we're also going to do the same thing for write. So anyone can read, anyone can write, and that's just for our top level playlist object. This is going to be our context object. So because it's our top level and our context, we're also going to create a nested set of rules for another one of our types. We only have one other type, and that is track. So I'm going to enter track here. I'm going to do the exact same thing and give it the exact same sets of fields here. It's going to take a field called actions, and it's going to take an array of rules again. So what can we do for this set of rules? I'll open this up, but I will add that the requirements for our application were such that any user who creates a playlist can add tracks to their own playlist, but nobody else can. However, they can also share their playlist with friends, so anyone should be able to see what tracks they've added. So based on that, what do we think goes under who for our first rule set here? Author. Yeah, definitely. Love that. All right. Now we also have a property called of this time because we're saying who, author, of what, can, read or write. So we can plug in a value here. What does everyone think we should add here? Playlist, yes, definitely. Awesome. Good stuff. Okay, so we said author of playlist can do what? Right, yep, that is definitely correct. Perfect. So our next rule set is going to have to do with something else. So we're going to say who, and what do we think? Anyone? Awesome. Great. And can, there's only one more option here, but what do we think? Read. Awesome. Perfect. Yes, this looks really good to me. So we have our types. We've got two objects here, our playlist and our track. And then we've got our structure. And within our structure, we have a top level item called our playlist. We have some rules here that anyone can read a playlist and anyone can write a playlist. This is our context. And then we also have a track nested under that. So playlist is going to be the parent of all of our tracks. It's also going to be the context for all of our tracks. We have rules here that the author of a given playlist can write tracks to it, and that anyone can read the tracks belonging to a playlist. Okay, so this looks really good to me. I feel great about the way that our protocol looks. This is actually all there is to defining our protocol, which is wonderful. So now we can actually go into our application. We're going to pull a little Martha Stewart trick because this is actually all already written, but we'll go through the code together and we'll talk about what we're doing at each line here. And then we'll go ahead and run our application and see what we've got. So the first thing we want to do is import Web5 into our application. And we're also importing our API key that we defined in our config file here. So all I'm doing here is I'm actually just grabbing references to each of my elements in my DOM. And then right here, I'm connecting to Web5. It is it's wonderfully easy to get started with Web5. Absolute props to the Web5 team as well. All you end up doing is calling web5.connect, and you have created a Web5 reference and created a DID for your user. Every time a user visits your application, they'll have a DID generated just for them. And we'll also have a Web5 reference so that we can interact with their DWNs, their personal data stores. So once we connect to that, we just want to make sure that we actually do have that reference. So we're calling that. In our application, we've created a loading screen. And the first thing that we're showing our users is that we're loading Web5. Once we're able to call into Web5 and we've got our reference, we can go ahead and change that to loading tracks and let them know what part of the process that they're in here. So let's go ahead and pass this over to Clara now, and she can take us through some of the TIDAL API stuff. I do want to go over some of the protocol rules first. So I'm going to remove this, and we're just going to use the protocol that we've actually just defined. If you're following along, you can feel free to do the same thing as well. Once we have our protocol, we're going to first check and see if the protocol exists in the user's DWN. And we're going to do that by querying for the protocol. And we're going to pass it the name of our protocol. I'll show you where this maps to. Over here, we have protocol and we have this URL. That is effectively exactly what we are passing right here. So that's all we're doing. We're passing a URL that matches the protocol that we've just defined. Now down here, we're checking to see if the protocol exists. If it doesn't, then we want to install that protocol. We're going to do that by calling configure on our Web5 DWN protocols. And we're going to pass it the entire definition. So this entire JSON object here, this whole thing is what we're passing in to here. So like, for example, like we could instead replace this with this, but we want to be pretty clean here. So we're just calling a reference to it. So once we do that, we've done this locally at this point. Everything that we've done is we've queried locally, and then we've installed it locally. Once it's installed locally, we also want to make sure that it's installed remotely. So we're going to call on the protocol that we get back. We're going to call send. We're going to send it to our user's DID, and that's going to send it to their remote DWN. When a user has a DID, to kind of lightly touch on this, it effectively resolves to a DID document that is able to route to an endpoint where a user's DWN would exist. And what this is doing is it's resolving the DID to a DID document. It's looking for metadata to see where that remote DWN is posted, and then it's sending this protocol so that it's installed both locally and remotely. Okay, great. So I think at this point, we're almost there. Now we're just checking to see if our user has visited our site before, and we're seeing if they have a playlist context created yet. So we're going to query their records. We're going to pass that protocol URL again. So just to take us back again, that was this string here. And we're going to say protocol path playlist, because that's what we're checking for. To show where that exists, that's under structure, we're passing this key right here. If we don't find anything, it's safe to say that our user does not have a playlist created yet. So we're just going to go ahead and create that context. So we're going to call write on their records. We're going to pass that protocol URL again. The protocol path is playlist. We're going to pass it our schema over here under types. That's just going to be this exact string. So that's all it's doing there. It's just passing that exact string that's defined in our protocol. And we're going to set published to true so that other users can query for this protocol, or for this playlist, I'm sorry. So we're going to do the same thing here. We've done this all locally at this stage. We've queried locally. We have written it locally. We're going to now send it to our remote DWN. So we're getting the playlist record that we're getting sent back. And we're just calling send on that, once again, to the DID. Okay, so now we have a playlist record reference, and we can use this as our context object when we're adding tracks to our playlist. So I'm going to pass it to Clara now, and she can take us through some of the API work that we see here. And I will be your hands.
Super. Thank you, Kirah. Okay, so now to be able to use the TIDAL API endpoints, first we will need to get the access token using this TIDAL endpoint we see in line 67. We can see that for the authorization, we are using the API key, which is the base64 encoded client credentials that we obtained previously. And then with this token, we will be able to fetch the metadata of any artifact type from the TIDAL catalog, such as albums, tracks, videos, or artists. So once we have obtained this, the access token, for the purpose of our playlist maker application, we will use two endpoints from the TIDAL API. The first one, it's this one exactly, which is the get single album endpoint, which retrieves album details by the TIDAL album ID, which in this case is that one you can see there. And this endpoint will give us information from that corresponding album, information such as the title of the album, the artist name, the duration of the album, the date it was released, the number of tracks and videos, if it contains videos, the image cover of the album, some media metadata such as the sound quality of the album, lossless, high resolution FLAC, and so many information. And then the second endpoint that we will be using is this one from line 91, which is the get album items, and which retrieves a list of album items, which can be tracks and or videos, by the album ID. So this second endpoint will give us information of every track included in the album or every video, such as the title, the duration of that track, information about the copyrights, for instance, or identifiers such as the ISRC, and so on. So with these two endpoints responses, Kirah, what else are we going to need?
Yes, thank you. Perfect. So now we have our references, our album res response and our tracks response here. All we're doing here is we're falling back to some static information. But once we have all of that, we're going to grab our album and our album tracks, and we're going to go ahead and start to render a lot of that information in our UI. So we've got some more work here. We've created a button in our application that will allow users to copy their DID so they can share it with others. And we're just going to go ahead and help them copy it to their clipboard with that. We're also going to console it and or log it in our console so that we can see it printed out for ourselves. We're also going to take our album image information, and we're going to go ahead and render that for our users. We're also going to get our album title and render that for our users. And then we're going to get the artists from the album. We're going to go ahead and render that for our users. The next thing that we want to do here is we want to check and see if our user already has added tracks to their playlist in the event that they have a playlist created. So we're going to go ahead and query for that. And we're going to pass that URL once again, our playlist protocol URL. So this guy right here. And this time our protocol path looks like playlist/track. And the reason for that is because in our structure, we have our top level item playlist, and then we also have a nested object here called track. So we're checking for any objects at that path to see if we can go ahead and already pre-select the same tracks that they've added to their playlist for a smoother and better user experience. So we're going to go ahead and loop through each of these tracks here. We're going to do our rendering. And then we're going to write the code that allows them to select and deselect tracks so that they can continuously update their playlist. So we're going to write our track information, everything that we're getting back, to that user's DWN. And then we're going to add some metadata here. Once again, it's the protocol URL. It's our protocol path, playlist track. We're going to pass it a context ID. So if you remember earlier when we wrote our playlist much earlier, we would get back a record, an object, and one of the fields on that object is called context ID. We're going to pass that to our context ID here so that they share the same context ID. We're just going to use it again in our parent ID as well so that we know that the playlist is the parent of our tracks. We're also going to pass it that schema URL that we defined, and that one is this guy here. And we're going to set that published to true. So we're going to do the same thing here where we send it to our remote DWN, and then we're going to do a little bit of work to render it. Now, if our user wants to actually delete a track from their playlist, then we're also going to allow them to do that. We're going to call delete on records. We're going to get the record ID. So when we added the record, we also decided to add an attribute called data record ID, and we just got the record ID of that track as it relates to our DWN. Now we have access to it so that we can find it in the DWN and then delete it. So we're going to do that locally, and we're also going to do that remotely. All we have to do to delete something remotely is we can just plug in our user's DID into a from field, and it will, again, resolve the DID to a document, and it will look for that endpoint to find that remote DWN. Okay, so a lot of this is just rendering our track again. We've got a few things. We've got like the duration of the song that we want to render for our users. We also want to render the title for our users. And we also want to render an image for our users, which we've done a little earlier. Now down here, we're just kind of adding some fallback error messaging so that our user can experience a little bit of a better experience. If we fail to get our tracks from the API, we want to let our user know. And if we fail to connect to Web5, then we also want to let our user know. And that's all that we have for our first application. So let's go ahead and serve that and see what that looks like. So if you're following along, you can actually go into the README here, and you can just take this exact command, and I'll actually do that. You can go ahead and plug that in, and it will just open it right for you. I'm going to go ahead and share my entire screen so we can actually see what that all looks like. So this is what we've just built here. So we have a button, and we can copy our did. And I just want to show everyone what one of these looks like. So let's copy our did. And now we can see it in the log. It's also been copied to our clipboard, so I can go ahead and paste it somewhere else. And we can also see all of the tracks that have come back from our TIDAL API. So if I want to add a few of these to my playlist, I can just go ahead and do that. I want to build a personal playlist. And I'm going to add a few favorites. So I can just play these on repeat if I want to. So I've now added these 3 songs to my personal playlist. Traditionally, in a Web 2 world, I would be locked into this application if I ever wanted to access this information again. So I couldn't go somewhere in a Web 2 world and be able to pull this playlist and see that these 3 songs are my favorite. I would have to go and figure out what my favorites are again. In a Web 5 world, that changes because now this data is actually associated with my personal data store. And we'll see what that means for us as a user in just a moment here. I'm going to pop it back into our code here. And now we're going to go and take a look at a completely separate third-party application that we've made. Let's just imagine that we are completely different people. We have not communicated with the makers of Playlist Maker. We have just decided to create an app that makes use of the data that is associated with the protocol here. So all we need as the developers of Playlist Finder is an awareness of the protocol. And that way we know how we can manipulate the data to serve our users' needs. So in this app, what we're doing again is we're calling web5.connect again. We're throwing in some loading screens, some error handling for a better user experience. And then we're getting the playlist from our user's DWN. And all we're doing is querying for a context record at the protocol URL that we saw and the protocol path playlist. So we're going to query for that. If the user has a playlist, then we're going to be able to also query for tracks. And we're going to do that by passing in a protocol URL again, the protocol path, this time playlist/track, and the context ID of our playlist record that we got back when we queried the first time. If they have a playlist, but they haven't added any tracks to their playlist, we're going to let our user know, and we're going to add in some error handling. Otherwise, we're just going to go and loop through each record, and we're going to render that on the screen. If the user has never visited Playlist Maker, they've never created a playlist, we're going to let our user know. And if we have accidentally entered the wrong did or something has gone awry, we're going to let our user know. Something went wrong with actually fetching that user's did. And if we have trouble connecting to Web 5 at all, we're also going to let our user know about that. So let's go ahead and serve this and see what that looks like. I'm going to go into our README again, and I'm going to look for those instructions again. And I'm just going to copy that and paste that here. And let's see what this looks like. So right now we're loading Web 5. Now we can actually enter any did here to get the favorite track of anyone. So I'll go ahead and go back here. I'll copy my did. I'll go here. I'll enter it here. I'll hit go. And I can see every single song that I've added to my playlist. This is, again, without using an API to connect these 2 applications to one another. These 2 applications actually never have to communicate with each other. They only have to communicate with a shared protocol. So I want to take a moment, if everyone's had a chance to serve this locally, I want you to go ahead, select some songs, and then copy your did. If you were unable to follow along locally, you can still jump in, and I'll show you how. We've actually gone ahead and deployed this on Netlify, and the link should be in the chat. We'll just let that load. I want you to go here, and I want you to go ahead and copy your did. So these are to be clear, two separate applications. Your local application and this deployed application will have two different TIDs for you. So I want you to go ahead and use just one or the other. But please do go ahead and copy your DID. And then you can go ahead and go to the other application here. You'll start with Tangerine Gumption. And you can go ahead and plug in your DID again. Now this was my local DID, so I can see all my songs once again. So I will stop sharing for now. I'm gonna come back here and I'm just gonna see if anyone has any questions. Okay, I see some messages about getting an error with loading tracks. So it's quite possible that is related to your API key. So there may have been an error with getting your base64 API key. I wonder if Clara, you can jump in if you have any tips for them.
I would say just check that you have copy pasted the base64 sliding credentials obtained in the config.js file from the playlist maker application, and then try to run it again locally, maybe clean your cache, right?
So I had some problems like this last night, and what I discovered was my browser wasn't had saved in cache the initial version of the application, but didn't have the token correctly. So even though the token was right in my JS file, it wasn't right in my browser. And what I ended up having to do, and I can share my screen really quickly and show what I did. That was go into developer tools and clear my cache, like have it disable the cache for that doc. Just to kind of troubleshoot those sort of things. And while I'm bringing that up, if there's some other questions in there as well. Let's see. So I've got the app up here. I'm going to go to more tools, developer tools. And it's not messed up at the moment, but if I reload this, you'll see that it's going to start hitting the API to get the token. Like this is the request. What you'll want to look at is make sure that this authorization line here, this value here is the value that you got for your token. If that matches, then it's possible that something went wrong in the process of doing the base64. And again, I have another encrypted file that string that I'll be deleting from my configuration since it's now on the web.
Okay, great. So I'd love to open up the chat again and just see if there are any other questions about anything we went over today. And by the way, if we're not able to answer any questions, we absolutely will be sending out an email afterwards to follow up and make sure that we get all of the questions answered. I see, why are there two different deployment links? So these are two separate applications, and this is just to demonstrate the interoperability that open protocols provide. Although we did build both of the applications ourselves, if Clara and Erin and I did not know each other, but we all had an awareness of the same open protocol, we could build applications that exist within the same ecosystem, and we'd be able to help users bring their data across all three of our applications without ever needing to communicate with each other. No problem. Are there any primer docs we should peruse to build similar sample apps? Yes, so in the README of the repo, there are a few links. I'm just gonna get that and drop that in again here. 1 second. So I'm gonna drop in the README links here from the repo. So you can visit the TIDAL API reference, the TIDAL dashboard, and the TIDAL discussion forum to learn more about the TIDAL API. And you can also visit the TBD developer docs, the TBD community Discord server, and the Web5 homepage to learn more about working with Web5 apps.
To prove Kirah's point that these were totally separate apps, if you look in the issues section of the repo, I shared my did. If people want to see the playlist that I created, you'll be able to see that in the decentralized way that open protocols, to see the promise of open protocols. Yeah, so if you want to post it, what I would suggest is go to the repo, go up to the issues section of the repo, and then you can just post an issue with your did. Yeah, thank you. And as long as I think the person who shared it did their app, their playlist maker app will need to be running for this to work, but because it's actually you're communicating with their apps through this, which is super cool, right?
Erin, Kirah, and Clara, if there are no more questions, I would like to thank you for this super exciting workshop. I think everyone is super excited to see that TIDAL has now a developer API that we can use, and the power of Web5, which allows you to build decentralized web applications. I think everyone will go out to the GitHub, explore the links, and explore all the possibilities that open protocols can provide. I would like to thank you again for sharing all this knowledge with us, and I would like to thank everyone for attending this workshop. I'm sure you will find more information about this, and enjoy your day, evening, wherever you are. Thank you, everyone, for being here today.
Thank you all.
Bye. Thank you all.